All right. I think we're ready to start. Seems like a U shape in the room. Sort of more of a, I don't know, what letter is it? It's not really a U. Lowercase m. Well, I guess it depends on if we fill in the front here, right? All right. Anyways, I'll go ahead and get started. So at 10:45, who's very good with clocks? Anybody? 8 o'clock. Everybody with their eyes open, right? Okay. So if I am still talking at 10:45 and I haven't talked about what you need to do for Thursday, somebody needs to interrupt me because we need at least 5 minutes at the end to talk about what you need to do for Thursday. All right. Does that sound good? And I can't delete the quizzes from last Thursday because somebody answered all of them. And I can't delete quizzes once they've been answered. But don't worry. You don't need to go answer them. It won't count towards your grade. If I had deleted them before anybody answered them, I could delete them. But now I can't. But don't worry about it. All right, there we go. Okay. Today, I want to talk about automation in manufacturing because we use computers to do automation in manufacturing. So automation in manufacturing is a topic of computer-aided manufacturing. That makes sense? All right, so manufacturing is making stuff with the intent to sell it. That's my definition of manufacturing. So if you don't know that, you should know that. Manufacturing is making stuff with the intent to sell it. So the making stuff is the manufacturing processes. And as engineers, we spend a lot of time studying the manufacturing processes and learning how to optimize the manufacturing processes, learning how to do the manufacturing processes. But it's only manufacturing if we're intending to use those processes to make stuff that somebody else wants. Okay, quickly, how do we know that they want the stuff we made? Yes, they buy it from us, right? We know they want it because they pay for it. We know we did a pretty good job when they buy it from us again, right? So this is manufacturing. Okay, so we're going to talk about manufacturing education. We can talk about manufacturing education too. But if we're going to talk about manufacturing automation, we're going to understand that manufacturing is making stuff for other people. Okay, so what's automation? It's two words, right? So manufacturing automation. What's automation? It'd be really boring if nobody answers. So you said taking a process that's normally done manually and having some other machine, some mechanism do it, right? So having it happen. So automation is removing the human from the process. Can we say that? So automation is removing humans from the process. All right, so this is what we're going to talk about. We're going to talk about making stuff people want without people. Manufacturing automation. What's the first thing you think of when I say manufacturing automation? Wait. Here. CNC, okay. What's the first thing you think of when I say manufacturing automation? Oh, the little hat fell off. Don't worry. Manufacturing robots. What's the first thing you think of in the back when I say manufacturing automation? Okay. All right, so we got CNC machine tools and stuff like that. We got robots. We got an automation line. I'm not sure, so I've been around manufacturing automation for a long time. I do think a lot about like an assembly line kind of thing that gets automated. Like I picture like the automobile going down here with like you see the chassis going down, and then somebody's putting a seat in it, and then somebody's putting some other stuff in it. And so the part of the process that we automated there was the motion of the vehicle past the assembly steps. Does that make sense? I also see like a 6-axis robot arm in welding some part of that chassis or welding some parts on the automobile as it goes down that line. So I'll frequently see that kind of a thing. Now, actually using the CNC machine itself is an automation step, right? Right. It gets us away from the Etch-a-Sketch style of machining of turning the two handles to programming the machine and having it work. So the CNC machine by itself is an automation. The assembly line we've all seen the factories with the cars going down there, right? We've seen it on TV or something like that, right? Who's ever consumed a beverage from a bottle? So the filling of those bottles and the manufacture of the beverage that went into the bottle today is almost always automated. And you'll see these bottling plants. I think they've solved this problem. I think it was a WPI MQP. There's a beverage company called Wachusett Brewery that's not too distant from here. So they had the particular type of container they put their beverages in that was hard to automate the system. I think it was a WPI MQP that sort of helped them figure out the hard part of it. I don't have details though, but I do know that before they figured out how to use an automation system to bottle that, they would get the neighbors to bottle it, and they would give them free beer and pizza in exchange for helping them bottle the beer. So I guess that's sort of casual help, right? Hiring casual labor. It's pretty casual when you're getting paid with beer and soda too, or beer and pizza. All right, so I'll think of that a lot with automation. There's really two different types of manufacturing that we can talk about when we look at automation also. There's what I like to call high volume manufacturing, and that's what we've just been talking about. We're picturing the bottles coming through and having robots fold boxes and having robots put the bottles into the boxes and the automatic filling stations and all that. And so that's like a high volume kind of manufacturing facility, or the automobiles going through there. What are some other examples of high volume type manufacturing automation that you could think of? Anything else? It's got to be out there. Yep. So food products, things like that. Injection molded plastics kind of products. Those systems tend to get automated. All right, so that's high volume. The other kind of manufacturing that could use automation is what I call high mix manufacturing. And so high mix manufacturing is the kind of thing that we see in like a CNC job shop. It's where they maybe make 100 of this piece, maybe they make 1,000 of this piece, then they're making 500 of this piece, then it's 10,000 of this piece. And they're making production volumes of parts, right? So when you're making 1 or 2 pieces, you'll call that sort of prototype manufacturing. Even if you're making 1 or 2 pieces for a production item, you sort of consider that, because they're just the amount of time you spend setting up the job significantly outweighs the amount of time that you spend making the parts. And so that's more of like a prototype manufacturing. And this high mix manufacturing is somewhere in between prototype manufacturing and that high volume manufacturing, where you're making the same part day in, day out. I mean, I guess at the bottling facilities, they're not always putting the same beverage in the bottle, but they're always putting beverages in bottles, right? It's not always the same label, but it's always labeling on the bottle. And in the high mix manufacturing area, it's more like, well, it's often the people making the parts aren't involved at all in the design of the part or at all in the sale of the part afterwards. You know, they've got General Motors that wants them to make this bracket for the seat belts in Corvette. And so they're making Corvette seatbelt brackets, but they're not selling Corvettes, right? They're selling brackets to General Motors, who then puts them in the assembly line and does that stuff. So in that, and they may be making brackets for GM and Ford and Toyota, all in the same shop, all in the same day even, but they're switching machines and switching what they're doing. So it's high mix manufacturing. So we've got high volume manufacturing and high mix manufacturing. And this automation is the taking the humans out of that process. Now, if we're deciding to automate something, what would make us decide to automate a step? What would our rationale be? Whether it's high volume, high mix, doesn't matter. What's our rationale? Why do companies automate steps? So they want to be faster and cheaper. Does that actually? Nobody that's watching at home can see that. All right, faster and cheaper. Why else? So faster, cheaper, better. So remove errors. Faster, cheaper, better. Why else would I automate? So one of my early engineering jobs was working for a company that actually designed and built automation systems for manufacturing facilities. Who's ever used a plastic spoon? You've all used a plastic spoon. Who's ever seen a plastic spoon manufactured? I have. All right, so plastic spoon manufacturing. So they're injection molded. And so we get this idea of injection molding. Who is there anybody that can't visualize what injection molding is? You've got a metal die that's got some way of opening, so you take the parts out of it, right? So there's a metal die that's closed, and under high pressure, you push molten plastic into the die. And it's injection molded, and then you cool the die very quickly. Well, you could do it slowly, but quickly is faster. So you cool the die very quickly. You open the die up, you take the part out. So you could do that one spoon at a time. You could, right? You could make one spoon at a time, or you could make 50 spoons at a time, right? The way you make 50 spoons at a time, the cross section of your die is going to look. One more. It's going to look something like this. So you've got I'm not going to draw 50 of them, but you get the idea, right? And then the spoon. And you could picture spoons populated on all that. So we'll call this like the tree, because it looks kind of like a tree after you take the limbs off. So it comes out as this tree with maybe 50 spoons on it and gets set on a table. And so what their process was with that was they'd take those trees out of the injection molding machine, set them on the table. When they had 10 of them stacked up, the operator would go down both sides of the tree and go like this. So they would fatigue the little bit of plastic right here and break the spoon off the tree. Does that make sense? So why do they want us to automate this? Because labor was pretty cheap. Like the cost of doing that, and it was the person that had to be standing there anyway to unload the machine. So every 10th one, they would do this. While they were making 10 more, they would keep doing that. Why were we automating that process? Oh, no. So there's this idea that there's manufacturing jobs that are dirty that nobody wants to do, right? There's this idea. Here's my experience. Hungry people do those jobs. So there's people that want to do that job, right? There's people that are swimming across rivers to come to America to do that job, right? So there's people that will do the job, and especially if they swim across the river, you pay them on the table. You don't have to pay them minimum wage. I mean, that's against the law and all that. But so it's not because nobody wants to do that job. And if it was because of the cost of like you couldn't afford to pay somebody to do that job, then maybe it was to make it cheaper. But they had plenty of people, and that person actually got paid pretty well to be an injection mold operator. So as those kind of jobs go, they get paid pretty well. So why were we automating it? Nah, same amount of time. Actually, our process might have been slower. Nah, you wash your hands, you do that. I mean, people that do cooking, they touch food. They can make them wear gloves, so it's not cleanliness. Why did we want to automate that process? Because they get tired of paying workman's comp claims for carpal tunnel syndrome. So we were improving the safety. So we want it faster, cheaper, better, safer. Why else might we automate something? It might be because nobody wants to do the job. But it's fairly easy to find people to do, shouldn't say easy. But there's people that can do most of these jobs that we automate. And so on safety, it could be things like ergonomic safety, like this carpal tunnel problem that we were having at this particular job. It could be putting stuff in and out of a furnace while it's still hot. Right? There's some safety issues with going in and out of a hot furnace. There's some safety issues with accidentally being in the furnace when the door gets closed and they fire it. That happens in places with hot furnaces. So if you never have anybody that has to go in the furnace, that's better, right? Right. We've all seen the movie where you get in the trash compactor and there's the alien thing swimming around in there and they turn the trash compactor on and crush us. We've all seen that, right? I mean, I guess they weren't doing manufacturing in that case, but you could picture these kind of hazardous places where you don't want to be. When I was roughly your age, I worked at a nuclear power plant, and I was there during a refueling operation, which they do every couple of years, and they have a site-wide announcing system. And that's how you talk to like if you want to talk to somebody in the control room, you just press the button and say, this is so and so. I want to talk to the control room, and then you'll do a private connection from wherever you are, but you do the announcement across the whole thing. So we had an announcement from the control room that said, attention in the plant, attention in the plant. We were declaring a site emergency. Now the reactor's shut down. We're in the middle of refueling. We're declaring a site emergency. A fuel rod has been lost inside the reactor. And it said, all unnecessary personnel, please stay clear of the refueling floor. I'm thinking, shouldn't they have the unnecessary personnel report to the refueling floor for diving operations? But they automate that motion of picking up the fuel rods and moving them around. And so the way you load up nuclear reactor is like the new stuff and the old stuff, it gets moved around, and you shuffle it around. It's like trying to make cookies bake evenly in your oven when you got more than one tray. So you get a better distribution of the flux in there. And so anyway, their process was to go in there with a little robotic arm, pick up the bale. There's like a little hook on the top, just like Christmas ornaments or whatever. Pick up the fuel rod. They would then go to the center of the reactor, lift it to the transport height. Then they'd move it to the spent fuel pool, or they'd move it to wherever it was going to go. So they get to the center of the reactor, moved it up to the transport height, and realized that it wasn't there. Turns out, when they found that it was right where they had left it, because they closed the bale and then they closed the hook, crushed the bale, then opened the hook and went to move. So it was like operator error on the crane operator. But you can't swim down there and pick these things up. You can't send divers in to do something like that. So that process has to be automated. I suppose you could send divers as long as they're unnecessary personnel. All right. So, but we're talking, I suppose it's manufacturing electricity. We're talking in manufacturing though, but automation happens in all kinds of industries. And for those, I think, so to improve quality, to reduce cost, I mean, these two really kind of go together, right? Because time is money, right? Those two those certainly have a lot of overlap because cost has a lot to do with time. To improve safety. Are there any other reasons that we could think of that we want to automate a system? Yeah. So, we like to talk about lights out manufacturing. I read a book by a guy named Jay Black who teaches at Auburn. And Jay said that the title of the book was The Factory of the Future. And he says, in the factory of the future, there's going to be two employees. There's going to be a guard and a dog. The guard's job is to feed the dog. The dog's job is to make sure the guard doesn't touch any of the damn machines. Right. So one of the reasons is to reduce the number of people required to do the process. And a lot of times we think we're doing that to make it cheaper. But in today's workplace, there's actually millions of jobs unfilled because of a lack of people either skilled enough or willing to do those jobs in manufacturing. And it's not because they're the dirty jobs. It's not because it's this job. It's because they haven't had the right training. They haven't taken that step. It tends to be the clean jobs, the jobs programming the machines, jobs programming the robots. Those are the jobs that are hard to fill in manufacturing. So often we might be automating something just so that the person that is doing it right now could go do something more useful. And so we're removing people, but it's not because we're going to fire people. It's because we can't hire enough people. I talked to a guy. They own 10 manufacturing companies with about 50 people at each facility. So about 500 employees. They're spread out through northern New England here. And he told me that he would hire 200 people today if he could find them. And it was these skilled jobs, not the dirty and dingy jobs. It was the skilled jobs that he couldn't find the people for. So he's got 500 employees-ish. I've never asked him how many total, but I'm guessing about 500 employees. He would rather be 700 employees. He can't find the people. So we were talking about developing an automation system for one of his processes so he could take the people that were doing that job and have them go do something else. And so these companies can't grow without this idea of automation. So and I talked about high mix. So what he's doing is high mix manufacturing. He's got a bunch of job shops around New England. And we've got high volume manufacturing. And the two kinds of processes really require different kinds of automation. So is everybody sitting near their group? Could we quickly group up? Is there anybody that's solo from their group? No groups has got a solo practitioner? Okay. What I'd like to do is just take a few minutes and think about high volume manufacturing. So this is like our bottling lines and our assembly lines for vehicles, and so there's a company in near Worcester that makes lasers. Company near Worcester that makes lasers, and they sell a lot of these lasers. So they look like a machine shop, but they have one particular part. I know they have 7 machine tools operating 24 hours a day, 7 days a week, making that one part. So they get grouped in high volume manufacturing, not high mix, even though they look similar. If you walked in and just looked at the facility, you'd think, oh, this is a job shop or something like that. And you'd think they were high mix, but they're really high volume. So if you think of these high volume manufacturing facilities, you can take a couple minutes right now in your group, make a list of the kinds of processes that you think would be good to automate in a high volume manufacturing area, and then sort of an idea of how you would automate it, right? So don't go looking up, oh, I want to get a 6-axis robot from this manufacturer, and then we're going to have these sensors and stuff like that. But just sort of visualize, get a concept level idea in your head of what it would take to automate that kind of a process. So just take a few minutes. Wow. I am 2 minutes off the schedule that I made for myself for this breakout session. I'm loving it. We'll take a few minutes, talk among your group, make a list. I'm not going to make you make a slide. Yeah, make a slide with your list. And then I'll make a quick thing where you can submit the slide so we can put them up on the screen. And if you're at home, see if you can text in or coordinate with your group while we do this. So yeah, remember we're talking about high volume manufacturing right now. So making a lot of stuff. Ooh, now that you're in groups, I can make it a group assignment. Perfect. So when you're done, you can go to the syllabus page and jump to today, and it's this high volume manufacturing thing here. I'd never used that jump to today feature before. Thought it was pretty cool when it worked. So we get maybe 2 or 3 minutes to finish up, and then upload the slide. It wants me to sign in. It's fine. It's group 1, right? You don't have to come up. I'll just toss you the mic. I'll put the screen down. All right. All right. So high volume, stock refinement, sizing. So what do you guys mean with that?
So we were thinking that when you first get it in from like a distribution center, you taking just like plywood as an example, you're getting those like 4x8 sheets. So
Okay.
cutting down so that you can then put in the fixtures.
So like if you were making cases or cabinets or something like that, you get 4x8 sheets of plywood come in, and you'd have some sort of automated saw to cut it up to the right sizing. Yep. There's people I know that do that in Worcester for making pallets and crates. Yep. So positioning the stock in the machine. So you mean like fixturing it in the machine or moving it to the machine?
We were thinking mainly if it was like a CNC milling operation, positioning it in the machine.
Okay, so like a robot. Like we'd have a pile of stock material over here, and my robot's going to go and put it in the machine. Okay. Right along those lines, you can definitely have the robot tell the machine I put the material there, and have the machine automatically close the fixture. Yeah. Extract the part from the machine. So just the opposite, take the part out. And so we call this machine tending in automation speak, machine tending. Okay. Repeat the above steps. Yeah. Inspection and QC. And so what do you visualize with this inspection and QC? I agree. I'm just trying to see what you visualize when you say it.
I was thinking, so we sort of talked about visual, like camera optic sensors,
Yeah.
sort of looking at it, looking for defects, making sure that it like meets the correct dimensions.
This very often happens in high volume manufacturing where you get the parts coming down an assembly line, or rather coming down a conveyor, and there's a camera looking at them. Sometimes it's just to see, are they in the right orientation to put in the box, right? And if they're in the right orientation, they keep going. If they're not, you kick them out of the way. They get cycled around until randomly they end up in the right orientation again. So, all right. So that's that kind of inspection QC you're talking about. Okay. And packaging. Okay. Palletizing, boxing, wrapping the boxes with plastic wrap, all that kind of stuff. Okay. Does any group think that these are bad things to automate? Anyone would take any of these things off their list? Okay. Let's take a look at the next one. Where's group 2? Can you get the mic safely to group 2? I'm the only one that feels comfortable throwing my mic, huh? All right, group 2. Wrong button. Group 2. Next page. All right. Okay.
There's a lot of like automation warehouse. And then on the next slide, we just kind of gave a process that we almost needed out. Like making a water bottle, tiny water bottle. Yeah, plastic before the mold, remove on the belt, and then the bottle get expanded to start. Liquid one is with water, just half the band on it.
Okay.
And that whole process.
Yep. I think I've only been to a few bottling facilities. I do believe that they typically make the bottles in a different factory than where they fill them, but you could vertically integrate that whole process. And yeah, you'd have to filter the water though, so you can call it spring water. All right, group 3, did you guys upload something?
Yeah.
So individual machining steps, drilling, stamping. Do you have the mic? Why don't you guys go through your stuff here?
So the first one, the individual machine steps, kind of plays in the industrial background. But if you've got a warehouse system, you can have two parts moving. People don't have to transport boxes of parts from one machine to another. One line makes one process simple. And we also have one control step on there. That's what we do. Not as fast. People have to do.
All right, and group 4.
It goes down to the different processes like transport. You can do the bare bones and rollers, heat treating, with like filling the ovens, casting and injection molding with the consumer process. Put something in mold. Assembly, or what we're locked on. Packaging, like anything like the boxes. Cosmetics, spray paint on them, stuff like that. And then loading and unloading on like trucks and bringing in and out of the factory.
Okay, And so one common theme I saw, I think, in everybody's list, and I'm the one that can't catch. Sorry, it's carpet on the floor. How bad could it be? I think I saw transport on everybody's list. Is that correct? Moving stuff from place to place. And so this can be done with conveyors. It could be done. We used to have somebody donated it to WPI, and it ended up in the manufacturing labs because nobody else knew what to do with it. We had a forklift, but it was an automated forklift. You couldn't sit on it or drive it. You could only program it to do stuff. And this forklift came from a large, high-volume manufacturing facility. And the goal was to transport an item from one machine to another machine. Heavy items, obviously. You don't use forklifts to move light things. And I think they had a track in the floor, like a magnetic track in the floor that it followed, and it moved around. And this was designed and built in the late 80s, early 90s, probably, maybe even earlier than that. And the factory it came from, they never could figure out how to use it well. So we got it because the task that it did before that was deliver cookies to all the workstations on Christmas. Right, but transportation is important. Now, the other way we transport stuff in automated ways, and the robots that do this kind of moving stuff around in factories right now are much better than that design was implemented. But why do we transport stuff? In manufacturing, why do we transport stuff? Because it's in the wrong place, right? The next operation that needs to happen is going to happen somewhere else. We'll try to make sure the computer doesn't go to sleep again. All right, so whether it's high mix or high volume, you want to think about should we automate it? And the should we is really, I mean, it's partly dependent on what are we going to do with the people that get displaced if we automate it. But also it's really, is this the thing? So what manufacturing companies exist to make a profit? So if we're deciding to automate manufacturing, is this the thing that's going to make it better for us to make a profit or not? And, or is it going to be the thing that increases the safety of our workplace? Often those decisions are based on profit also. It's expensive when you own a dangerous workplace. It's expensive to pay those workman comp insurance claims and things like that. All right, so let's look at our high mix manufacturing. And so before we talk about automating high mix manufacturing, let's sort of talk about the process that happens. Is that fair? So the first thing that's going to happen in a high mix manufacturing space is there's going to be either a new customer or an existing customer that asks for a quote for a part. So we could step back another step and say we have to find customers, right? But let's just assume that the customer exists, that somebody has done some sort of marketing to make the customer exist. And so they ask for a quote. And what do we give them when they ask for a quote? We give them a quote, right? So they ask for a quote. We give them a quote. They either like our quote or don't like our quote. Maybe they try to talk us down on the price. Maybe they take our quote at face value, or they just walk away, right? So there's a chance that we just lose them at this moment. But then if they like us, they want us to do the work, we get a purchase order, right? Once we get a purchase order, we schedule the work. We get materials. We get tooling. Now, we may already have these things, right? It's very rare at this point that we go get the machine tool we need. But it's possible. If it's a big enough job for a big enough customer, before you start it, you might buy a new machine tool. That's pretty rare. RFQ, quote, PO, schedule, get materials, get tooling. We set up the job. We run the job. Maybe we get some QC in there. We package. We ship. And we invoice. I will note that the only step in this process that we actually get paid for is mailing the invoice. Everything else we have to do before we can mail the invoice, but we actually only get paid for sending the invoice to the customer. So everything is about getting to the point where we can send this invoice. This is our process. So RFQ, quote, PO, schedule, order materials, get tooling, set up, run, QC, packaging, ship, invoice. We'll try to get to invoice as quickly as possible. Now, to go from RFQ to quote, what do we have to do? We have to decide how much it's going to cost us to make the part and how much the customer is willing to pay for it. Because those two things are not necessarily coupled. Sometimes the customer is willing to pay much more than it costs. Sometimes the customer is not willing to even pay what it costs, right? So here's engineering. And we may need to have some customer communications here at this stage. But but we do a bunch of engineering at this step. We do some more engineering here. Between these two steps. Okay, so picture yourself as a young engineer at a facility that does work like this. Let's say there's one other engineer that works there, some senior person that's in the management level of the business, and they have 50 employees, just so you can sort of visualize the place. So maybe 50 employees, maybe 25, 30 different machine tools in this facility. If your job, if you got hired into this company to figure out how to develop automation systems to make the company more profitable moving into the future, right? So the owner, the manager of the business, they've got this great foresight. They know that if we don't start automating, then we're going to go out of business. So we need to automate. And this is how a lot of them will do it, is they'll hire a young engineer and say, automate us. And this is because in the last decade, they hired a bunch of consultants and said, make us lean. And so they've been through this idea of becoming lean. Now they got to become automated. And there's, I was part of the ARM Institute, which is this group. It's a university industry collaboration. It's based at Carnegie Mellon, but WPI was a big part of writing the grants that got it funded. I think it got funded with $170 million from the federal government. To the purpose of the whole thing was to figure out how to help businesses like this automate. This is a critical thing in the U.S. economy right now. 70% of manufacturing in the United States happens at a business just like this. And it is manufacturing that drives all the segments of our economy. So 70% of manufacturing in the U.S. happens at a business just like this. They're very difficult to automate. So get back with your group, spend a few minutes, make another slide that says, what are the steps? Pick a step that you think is the most important step to automate first. So with your group, pick the step that you want to automate first in this process, and then some idea of how you're going to do that. What goes into automating that? Okay, so I am going to put up another assignment. You can assume that they have CNC machine tools, that you don't have to automate the Etch-a-Sketch part of this, because they wouldn't still exist if they didn't have at least some CNC machine tools. They would have already closed. But these businesses that can't figure this step out, they won't exist 10 years from now. They'll be closed. And all those people will be out of jobs. Actual operating the machine tool to make the parts. And so that could involve 5 machines. It could involve 1 machine. It often involves the machine tending part of it. Hardly ever have a part that doesn't go in the machine twice. So it goes in one orientation, comes out another orientation. All right, it looks like we've got some stuff here. Screen down. All right, so unmute the projector. Let's start with group 1. Where's group 4? We'll start with group 4. We'll find group 4.
So, when you thought that the most important step, fully automate, like, understand that, getting stuff on and off the machine, moving them from machine to machine, or you got it. Also, you're wanting flexibility as well. Producing a thing to sell is pretty important because that's
All right, so group 4 is machine tending. Okay. Group 3, do you have a submission up there?
Yeah.
Okay. Refresh.
So you said invoices are due POs. So all for the base, it's easy to reference if you want to update. Use that.
So I'm going to call that the sales process. As a just sort of an abbreviation, but it's the idea of receive a RFQ, send the quote, receive the PO, and then automatically send the invoice. Okay, so sort of sales. We should automate the delivery of functional whiteboard markers. I certainly like the idea of automatically sending the invoice when the shipping label gets printed, right? Because then you don't wait a day or two. I know guys with really small shops. Go ahead. You can.
Digital bills of materials or descriptions for the supplier sent you or database
Mhm.
formatting. So I don't know what's going on.
Yeah, no, I think this is an important step. I know guys that have smaller shops, so not with 50 employees typically, but they'll regardless of when they send the parts to the customer, they send out their invoices on Friday nights. You know, they work late after everybody else goes home on Friday, And these are like owner operators. So these are like the small shop with maybe 5 to 10 employees. The owner stays late on Friday night or comes in early on Saturday morning or whatever. It creates invoices for all the jobs they ship during the week. And this is problematic for those guys because if they're working overtime to get something out, well, then they might skip it for a week. And so now we shipped the parts 2 weeks ago. We haven't sent the invoice yet. And usually on those purchase orders, the terms are we'll pay you, you're lucky if it says 30 days after getting the invoice. Usually it's 60, 90, 120 days after they're getting the invoice that they pay. I once had a customer that was 30 days, it said on the contract, and I never got paid faster than 65 or 70 days. And the customer says, well, what can we do to make you, fill our orders faster? I said, you could pay on time. And so he moved me to net zero, payable on receipt, which got me paid in 45 days. Because they wouldn't even listen to, they're a big billion-dollar corporation. And they wouldn't even listen to your complaint about not being paid unless it was 30 days late. So I had to wait until it was 30 days late, and then they would pay it in 15 days. No, it was the other way around. They wouldn't listen until it was 15 days late, and then they would pay it 30 days after being 15 days late. So that getting that invoice out promptly is important. Wouldn't it be even better if at the moment they agreed to have you do the job, you could send them the invoice? So that was one of our solutions. Was we created a convenient online payment portal that they could use by logging in and swiping their credit card. And once they swiped their credit card, then we would start the order. So there's some ways around that, and some of this is changing as younger and younger buyers get into the market. Where's group 2? Group 2's in the back corner, right? Group 2. Group 2. Go for it. Okay. All right. So it's very, very similar to you talked about doing both the operations side, so the running the programs and the machine tending a little bit, but also that sales process of going from RFQ to invoice. Okay. And group 1. So the license agreement with Xometry says you can't use their system to generate your own quotes. So you'll have to make your own system.
I think what we meant before, like,
But something similar to that. Yeah.
Similar system then, but also like you have to be wary, and I think they always do this, like people don't take advantage of the system, right? Like, it can generate quotes that are massively underpriced. If you have something that you want to
Yeah, you just won't be in business very long, so it'll run out. Um, so, but so it's that initial step that you were focused on, that going from RFQ to purchase order step of generating the quote, getting it out there. Now, I'm gonna make the screen go away here. So that obviously ties in with the ability to automate that sending the invoice and all that stuff also. So through that end process, that sales process. And I think the last thing that I would automate in this kind of environment would be that machine tending part of it. And the reason I would automate that, so it's one of the first things we automate in the high volume manufacturing process. Because we want to get that operator that's busy at that machine to go do something else. In this kind of a situation, though, that machine tending, yeah, it takes operator time. Yeah, go ahead.
I think that quality control would be a step to automate that, because I feel like that would be a job done better by judge the quality of the time.
Maybe. The idea that a human could judge the quality of a finished product better is probably not true. And the reason I say that, I've actually got a pretty good example of that. So we were working, this was a WPI project, and we were working with a company that makes golf clubs. And so the process that we were looking at was the manufacturing of the shaft of the golf club. And has anybody ever bought a golf club? Only one of you, a couple of you. Well, but you've all purchased something like a golf club. What gets you to take it from the rack to the cash register? Besides your feet. I mean, I know your feet and your hands have a part in that. But what makes you decide you're going to buy this one instead of that one? Oh, they'll let you try it out first. So you swing it, right? You look at it. What makes you decide you want to try it out? The price tag. All right. So the price is certainly important in our decision, but assuming you can afford it, and yep, the appearance of it. A lot of times, they spend a lot of time and thought into deciding the appearance. That's not the only thing, right? So you get in your mind, all right, the brand of it. Is it the size golf club I need right now, right? Unless you're buying a whole set, but even then, but you look at it, and the studies have been done on this, by the way. All decisions to purchase, all purchase decisions are emotional. Then we look at all the data and we justify our emotional decision to purchase. But all that rationalization happens after the decision to purchase. People have studied this. Anyway, so it's that, I like this one. It feels good to me, right? You feel it. This is the right one. You try it out. And maybe if you don't like it after you try it out, you get a feeling for another one. But this is pretty normal. So anyway, they understood this. And so their criteria for the look of the shaft was very important to them. And they had I can't make this up. The guy's name was actually Joe. They had a guy named Joe, and his job was to take those golf club shafts. Yep, that's a good one. Yep, that's a good one. No, there's a defect in this one. Either rework or throw it away, make a new one. And that was Joe's job. It was not the only thing he did at the company, but Joe's job was to decide which golf clubs were good or bad. And they hired some consultant or some young engineer, somebody that was good at Excel. And they started looking at statistics for trying to improve manufacturing, right? So if we have a lot of failures, we want to figure out what's common about these failures so that we can make that not happen again. And they were able to show statistical significance that every day after the Red Sox lost, failure rates were sky high. And so either it was the automated grinding machine that was not grinding parts well because, I don't know, the people were stomping their feet, or it was Joe. And so it turns out Joe was pissed off if the Red Sox lost, and that carried into his work. And so we replaced Joe with a laser and a light sensor, and pulling the laser along the shaft at a certain speed, and then looking at how the variability of how much light got back to the light sensor. And we used Joe to train it, but not on a bad day. So we did use Joe to calibrate the system. But yeah, so a lot of times automating that QC step takes that operator uncertainty out of it. Not always. And sometimes you need judgment, right? And a lot of times on those quoting situations, you were worried about going out of business because you were quoting too low. A lot of times you need judgment to know, and they're pretty good at quoting based on how much it will cost to make the part. And if you think about it, the algorithm to do that automated quoting isn't that hard to figure out. You have to know how much is the stock material going to cost, how much are the tools going to cost, and that stuff you have in a database, right? You can look that up. How far does the tool have to move in order to remove the material that needs to happen in order to make this part? And how many times do you have to flip the part over, right? How many setups are there? And you can estimate, all right, each setup is going to take, I don't know, maybe 20 or 30 minutes in the initial setup. And then you can fairly accurately have an algorithm to tell you how much it costs. But that's only part of the price, right? The other part of the price is how much is it worth? So what's the value of the part to the end customer? Because you can't sell it for less than it cost. Well, you can't sell them for very long for less than it cost. But you want to sell it close to what the value is. I mean, yeah, you want to give your customers a good price. But if you're selling it for way too little, one, they may not believe you can make it if it's the first time you're working with them. So if you price it much lower than they think it's going to cost them, or that it should cost, they're just going to say, well, these people don't know what they're talking about. They can't make this part. And your profit margin will be lower if you can't price it high enough. So the value side of that equation is harder to figure out. Pretty sure the Xometry model is based on cost. They try to be the low cost provider. They push that down on their vendors. Yeah, I'm actually in a Facebook group with a lot of people that are Xometry vendors, and some of them love Xometry, most of them hate Xometry, and it's for that reason of pushing that cost reduction down the chain. And Xometry, last I knew, didn't pay very fast. So I actually think that so the reason that I would do that machine tending last is because in these high mix scenarios, there's so much variability in each individual setup in that machine tending. I know a guy in Idaho, though, that figured that out. And he had some part families. He got a quote from an automation company to automate machine tending for one part, but he really wanted it to be for a whole part family. And when it was $60,000 or $120,000, I can't remember what the price was, but it was much more than he expected to spend, the same cost or more than the machine tool that was doing the work would have cost. Then he realized that he had 270 different SKUs that he wanted to automate. He couldn't afford to do all that. So he and one of his engineers stayed late on the weekends, and they figured out a system that they could use to automate all of their SKUs with this one system. And now their robotics business of selling these automation systems is like 10 times bigger than the original business was. Because once they realized they had a good thing, they started selling it to other people. So machine tending tends to be hard, though. And that step at the beginning, when the customer asks you for a quote, what do they actually want? They've asked for a quote, but is that what they actually want? They actually want to be holding the part in their hand, right? The quote is a process they have to go through to get to the part. They don't want the quote, they want the part. And so anything you can do to speed that process up, getting them the quote out, getting it an accurate quote, programming the operations for the machine tool. So not having to figure out how to make the part once you've got that purchase order. If you can go directly from purchase order, I mean, a lot of times you have the tooling in stock and the material's less than a day away. So you can turn the parts faster if you can automate that upfront stuff. And yeah, I agree that the machine tending stuff, the more of that you can automate, the more machines you can have running at the same time, the more profit you can have. That is definitely a bottleneck in the system. Also, if you schedule your machines right, one person could keep 2 or 3 machines running at the same time. So you do have some leverage there. All right. Look at my schedule. But I think I'm at the step of talking. Yep. All right. I'm at the step of talking about what to do for Thursday. Group 1. You have a design for your gears, correct? Okay. Group 2. Oh, and so it'll be this assembly. What's I don't remember what group 2. What part are you making? All right. So we did some design work. What you need to be able to injection mold is some kind of foot, and you're going to have group 2's back here, right? That's I'm looking at the right people. You're going to make some sort of feet that's going to hold our base for our thing when it's sitting on the table. What you need to know is the diameter that your part needs to press into and how far. So if we look at like this, maybe we do something like this. So you make a part that's sort of U-shaped that can press into 2 holes at once. That way, getting the diameter correct and the spacing correct will be a critical thing. And if our part has 2 or 3 of these in it, that'd be good. So what you need to know is what this diameter is, how far this distance is, and what this distance is, correct? All right. Somebody give me a diameter. Oh, it's just way too big. We want to hold it in our hand. 1/4 inch. All right, so 0.25. If I want to hold it in my hand, how far apart should they be? Inch and 3/4. It's like this far apart. Which direction are you going to have them face? If the body, so if we've got our gears here, we've got our shaft here, we've got a body of something that is holding them. I was thinking to have them like one here and one here. You could orient them the other direction, right? You could have one that comes down like this on each side, but I would make them smaller. So what if this dimension is 3/4 of an inch. 3/4 of an inch, 1/4 of an inch, 1/4 of an inch, 1/4 of an inch between them. That's too close. 1 inch. Okay. Outside to outside. Nah, center to center. Center to center. It's easier to dimension that way. Okay. Gear people. This is going to be a hex, right? So which group is doing that part? Your group is doing this part. It's a hex. If you look at your part, this part is a hex, and the hex dimension is 3/8. Okay, the hex dimension is 3/8. We want to put a thread at this end, and we want this to be a press fit. The threaded end, 3/8 is bigger. What's that? I think this has to be smaller than 3/8 because of the way I drew it. So make this be a 1/4-20. Thread. And this dimension, I think I was going to meet with you guys to help you figure out how to set up the lathe, right? So when we schedule that appointment, we'll figure out what this dimension is because I've got a box full of bearings and I just don't know the number off the top of my head, but we're going to use the bearings from that box. All right, so the other group, this is you, right? You need to know this distance, and you need to know the pocket diameter for the bearing to go in, right? And on this edge, we want to engrave something. And on this edge, we want to engrave something. On the bottom, you need to make holes with this spacing that their 1/4 inch part can press into. Your two groups should coordinate on what the tolerances are for these two parts. And so what you might do is figure out what you're able to hold for your injection molding size, and then design this hole to make sure that it's a good press fit for those to fit in. So your two groups need to coordinate on the diameter of those holes. But the spacing is going to be, we said 1 inch, right? Yep.
How do you decide that?
I'm going to go find the bearings in the box and I'm going to tell you. Yeah. Yeah, but we don't necessarily have to couple those two things. So I will, because you should talk to Rodrigo about learning how to set up the mill. We're dividing the labor. I will give Rodrigo some of the bearings too. So when I go back to the office right now today, I'm going to get those bearings out so that I have it in hundreds of them. So that's why we're going to use those. Get those bearings out and you'll have plenty of them to measure, figure out if you can do it, to figure out how you're going to press the bearing in. We'll have to figure out how we're going to press their part in as part of your research. Yeah, so you're going to do 4th axis positioning. We'll have to have a part. You'll have to be able to hold it in the 4th axis, do these bearing holes, rotate the part over, do these holes, rotate the part over, do this engraving. Okay? So for Thursday, should have a presentation that talks about your progress on learning so far, right? It'd be cool if you have machined a part, but talk to us about your progress in learning so far. It doesn't mean that you have to have machined a part that is the finished part, just that you have machined a part. Okay? And I need to put you in touch with Adam Sears, who's going to help us with the injection molding stuff. Somebody from your group, somebody from each group, create an email alias and email me from the email alias so that I can put you in touch with anybody that I need to put you in touch with as the whole group. Okay? But your group especially, because you need help from Adam. All right. See everybody on Thursday. So Thursday should be a quick update on what you have learned so far and what your next steps are. This thing went out again. That's a fucking do that.